Okay, so welcome back to Vulkan010, and in this episode we want to look at the creation of the Vulkan instance, the debug utils, and the surface. Now I will be splitting these into smaller parts because I want to hit the 15-minute mark on a video. So yeah, let's get going. Come on. So let's look at the Vulkan instance. So I think I got this this part from the documentation. It basically says instances store per application state, and we can have more than one instance running on the host machine. And I think this part mainly refers to having like many applications with and each one can run an instance. Now, I think that this is like my reasoning. What an instance is basically loads the Vulkan driver and allows for communication with the GPU. And of course, it's the first step in sending data and commands to the GPU. Or I think this part is important because at one point I think I've read that the instance is actually called the loader. So the reason for this is I think that basically when we call or create the instance, we basically load the API into memory. Or basically we load the driver, right? So yeah, so basically we'll load the driver into memory and we can use it in our application. However, it is important that basically if we know how that usually let's say this is a block of memory and our application is basically stored as bytes, which are commands. This means that this API isn't attached to our space, it's somewhere else in memory. And I think this is an important part that we have to keep in mind, because later we will see that we actually have to go and get the function calls and everything. We will see in a bit. So let's continue. So we create an instance with this function vk create instance, and if we give it a quick look from our introduction, we see that we have smaller vk, which means it's a function, it's not a structure, and we have a create, and then whatever we want to create is basically the instance in our case. And I've drawn it like this. Basically this is the input, however, and this is like the output, but these functions, I think almost all of them return a vk result. So they don't return this, they don't return the Vulkan instance in this case, or the object. Instead, they have like something like this. Let's say this is our function, and this is like create info is one of our input, and then we have the vk instance passed as a pointer. So we basically have to pass it as a pointer from already created. So we created a variable and we pass it here as a pointer. And yeah, this is like a small detour, but I wanted to explain the logic behind these squares and the inputs and the outputs. Basically all Vulkan functions don't really have these inputs as a return, but it's usually passed as a pointer. So we call this vk create instance, and all create functions actually require a structure called create info. Now in this case, create info is again capital VK is a structure, instance create info. So basically, these create infos have the object name as after the VK, and then it's a create info. So another thing to mention is, again, if you watch the introduction, I won't be doing the or marking the S type. Basically stands for structure type, because it's very long, and it's basically copy of this, like it's VK or capital, because it's an enumeration. In structure type, and then it just follows this. It will be instance dash create dash info, all capital letters. And I think it's kind of unnecessary to write it out every time I've created these graphics. So let's look at the actual structure. Now, all structures have these p next, or all create structures have this p next, which stands for pointer next, and they refer to basically extensions or kind of structures that are part of the core Vulkan, but yeah, we can call it like one after the other. I mean, okay, let me explain it a bit clearer. Basically, when we create instance, the instance calling this function, we will the function will use this information. However, if it has anything in the pnext chain, and if the object or the create info has the API has something that can go into the pnext, or knows that can go, it will basically run, like if it's another create info, it will be create that object after we create the instance. In the case like the debug report callback create info ext, this ext means it's an extension, or the debug utils messenger. Basically, these will be immediately called or immediately created after we create the instance. And usually you can create the debug messenger after you create the instance, but it kind of if you want to catch errors with the instance creation itself, when we pass the debug utils messenger or the report callback, it will capture these. If you kind of didn't correctly filled this structure, it will give you an error. Anyway, so we'll look in these extensions a bit later, because these are kind of part of the debug utils messenger, or the debug utils. So we'll move next to the flags, and flags kind of work like properties that we can enable. Not all like objects have these, so they sometimes, actually often they are like you pass nothing, like 0, I think, because these are enumerations. Yeah, and speaking of enumerations, these again, maybe I said it in the intro, but yeah, this is how I made the enumerations. Basically, this is the first part, and because they kind of use the same pattern first, I just added their name in the box. So enumerate portability bit KHR is the only flag that we can set here, and this flag kind of enables the listing of physical devices, because we need the instance. Zoom out. We need the instance to create to query the system for the physical device, what kind of GPUs we have. So this list, I'm assuming, I haven't used this. This basically gives us a list of devices that will not fully support Vulkan 1.0 features, basically it will support Vulkan, but not all the Vulkan 1.0. I think this is kind of for really old devices. Yeah, so we move to the application info, and next we have after it we have layer count, enable layer count, and pp enabled layer names. We have the extensions. Basically these two represent an array of strings, because it's a C, and we have to pass a double pointer for arrays of strings. And so the same for the extensions, but we'll look those in a bit. For now, we'll look at the p application info, which is a pointer to application info structure. And here it is. And again, this typical style, it's a vk application info. We have to declare in advance this, or if you want to be a bit more clever, I don't think it's a bit clever. It's you don't want to declare it above the call. You can inline it in the, not inline, we'll basically call it, create the structure at the function call. But yeah, so we have the vk application info, and this is a good case where we can see that there is no p next possibility. I think maybe if we pass something to the p next, if we have the debug utils messenger in the create instance info, instance create info, it will tell us that we are wrongly passing. I think I haven't done it, so you can give it a try. So we have next p application name or pointer. Basically this is a string, no terminated, because we don't have a count. Application version, and then we have p engine name, is a string, basically the name of the engine version, and API version. And just had to pause it for a bit. So we have a p application name, application version, p engine version, and API version. And I've marked these as optional because they really are not important. If you want to create an instance, that's these are not, you can pass like a null here, and 0, engine name could be null, and engine version could be 0 again. It's not important. The most important is the API version. However, again, application name is a string, no terminated string. P engine name the same, but the application version, engine version, and API version is basically we have to do this. Version is provided as a single integer. This is whatever, using its bits to define the version. For this we have a defined macro, basically vk make version, and we provide the major, the minor, and the patch of the version. However, I think in more recent versions this is deprecated, and it's something similar, and it just adds the variant here. We have to provide the major, minor, patch, and variant. So version is basically, we can do this ourselves, but the macro does it for us. It's like encodes it, like this first bit is the major, these bits are the minor, and this part is the patch. And this is how we provide, like if we want to give the application the engine version. And the API version, of course, if we know what version we want to use. But if we want to always use like the maximum version of the API we have, or the driver has, or we can like check which features we want to use, we can use, or which version, sorry. So alternatively, we could check for the supported API version in our GPU driver via this function, vk enumerate instance version, and we passed pointer to sorry, a variable, predefined variable above,